Hello. Testing 1, 2. Are we live and direct at this moment in time? I think we are. Very good. So let's wait for people to get on. I think the sound's okay. I can hear it on the iPad. Welcome anybody that is getting online now. Hi, Kajal. Welcome along, mate. Good to see you. Hope is the sound level okay? Can you see my face and can you see the screen okay? If you can just confirm that, mate, that'd be great. Thank you. Excellent. That was easier than I anticipated. Thank you for confirming. Hi, good evening. Is that Lizzie? Good evening, Lizzie. Welcome to the live stream. Touch wood. It seems to be going okay so far. I can hear myself, see myself, and see what's on the screen. So hopefully it's a successful first venture into live streaming. We'll stick to the kick-off time of 6 p.m. So if you want to make a cup of tea, get a glass of orange juice, whatever you want to do, then we'll start at 6 p.m. sharp. 10 minutes to kick off. Thanks for your patience. Okay, I trust you can all hear it okay. I can see I just looked on my cell phone. I've got 17 people watching. My iPad says 1 watching. I'm not sure which one is correct, but hey ho. So if you want to just pop into the chat where you're from, that would be great. Obviously, I'm in Singapore. And it's currently about 31 degrees in the shade. I see. My cell phone is keeping up to date much better than the iPad.
I see. My cell phone is keeping up to date much better than the iPad. I see. My cell phone is keeping up to date much.
Aha. I'll turn off the phone, it'll stop the echo. No, Rashana, we have not started yet. Welcome, Sangeeta. Hi, Scott. Hi, Sarah. 6 p.m. start. And good morning to the United States, Dawn. Welcome along. Oh, hi, Hong Kong. Welcome, Hong Kong, to the show. And we have Delhi in the house. That's very good to see. Welcome along, Ranchana. Yeah, sorry, I've just realised that if I use my cell phone, I'm getting live chat updates, but it all seems to be working fine. Three devices. Oh, brilliant. Moscow, welcome along. Good to see you. Ankara, we are a truly international show at the moment. I guess most of you are from the IB Chemistry Facebook teachers page. If you are, that's great. If you're not, don't worry about it. Hi, Colin. Colin, sorry. And Jeddah, welcome along. So if you have seen the IA, which I shared into the Chemistry Teachers Facebook page, that will be very useful, and we'll give the marks out for that at about 6:15, 6:20 during the going through of the IA. So this is looking better than I anticipated. We've got 23 people in the live stream, and we've still got 5 minutes to go. So just in case you haven't seen the Facebook page, we will be doing two things today. First thing we'll be doing is going through a previous IA, which I submitted to the IB 2 years ago. It's a pure database IA. And then we'll be using an IA which has just been submitted this year. I'm happy to share the first one with anybody that wants it if they don't have it already, but the second one obviously I can't share because it's for this year's submission in November. So Sangeeta, perhaps it's a bit difficult for me to do it at the moment because I'm live streaming from a MacBook. I'm watching on the iPad and I'm checking messages on my iPhone. So perhaps after this, what I will do is I'll append the file to the bottom of the live stream, which will be shared in my YouTube channel and on the Facebook page. No problem at all. If you're already in the Facebook group, it is. If you go to the right hand side, it's in files and you will see it's there. But the one that I share today will obviously have the marks on it and the annotated document. So about 3 more minutes, guys, 3 more minutes. Thank you for your patience. Hi Preeti, welcome along. Two more minutes before we begin. I will begin at 6 o'clock sharp because I'm sure we all have days that we want to get to. Evenings, mornings, afternoons, maybe go back to bed. I'm sure someone will be kind enough to do that for you, Ranjana. That's an easy thing to do. Be careful though, there are a few IBDP Chemistry Teachers Facebook groups. I'm in the IB Chemistry Teachers group, and it has like a purple banner at the top. Hello, Wisconsin. Welcome, Michelle. Welcome to the show. Excellent. We've got Indian, America, Jeddah, Singapore, Hong Kong. 1 minute. 1 minute to go. Oh, not forgetting Australia. Welcome, Australia. Yeah, Vijay. Hi, Peru. Oh, excellent. Hi, Taiwan. Well, hey, you've made my day. Thank you all for coming. Let's wait for the clock to tick to 6. We said we'd start at 6 p.m. sharp, wherever you are in the world. Right, so there is 6 p.m. So thank you all very much indeed for coming. Really appreciate you giving up your time, and I really hope that you find something or most things useful within this presentation today. So a little bit about myself. I've taught diploma chemistry for since 2008, so that's 12 scary years now. I've taught in Japan, in Malaysia. I've taught in Guernsey, an island just between the UK and France, and currently I've been 4 years now in Singapore. I'm the head of Year 12, and I've been moderating and examining for the IB for the last 5 years. So I'm not representing the IB this evening. The reason I'm doing this is because I felt that there was an absence or a paucity or not enough information being given out to support teachers and indeed students when we're being asked to do database or indeed simulation IAs. There's very little that's out there to actually help us, and certainly I was in that position when it started a few years ago. So if I can do a little bit to help others, then I'll consider this a good use of everybody's time. Okay, so let's kick off. Right then, the IA, which was shared in the Chemistry Teachers Facebook group, was this one, which is the to what extent does the size of the central atom in HXH affect molecular geometry by using ligand close packing model framework? Now, first of all, the first things to do when looking at an internal assessment is basically not to do anything. It's to just read the internal assessment. So begin and start to have a read through. Keep an open mind. We are guided as moderators to reward where we see positive things, good things, and not to penalise for an absence of things. Now, to clarify that, just because they've missed something, we're not going to penalise it, but if they include something which is incorrect, we may well penalise it, and you will see that as we develop looking at this internal assessment. So the students started off in the standard manner. As part of the syllabus, I was interested in VSEPR, and then it goes on to talk about immediately the ligand close packing model. So the first thought is, great, the students read around the subject, they've investigated, so their personal engagement must be wonderful. But hang on a minute, maybe that does show PE, but we'll keep an open mind as we go through. He's underlined optimizing a model for bond prediction of group 15 and 16 using LCP and VSEPR as a basis and central atom as a predictor. Now, this is not a typical research question. It doesn't mean it gets penalised for not being a typical research question, but we need to be careful when we step outside of the standard 5x3. Now, when doing a database, the 5 independent variables in triplicate, good evening, Sungwan, 5 independent variables in triplicate, you often cannot do for a database. And for those people that have watched my video on how to do a database during the pandemic, you will see that I'm actually advocating that you have multiple independent variables, or you have multiple readings from as many websites as you can get, because the central idea is it has to look like 10 hours. If it doesn't look like 10 hours, you're not going to get the marks. So we'll park that for now. We'll just think about it, keep it in the back of our minds. There's a bit here about VSEPR, which is standard textbook stuff about bonding, non-bonding repulsion, from this person called Gillespie, who does arrive and appear quite a lot during this internal assessment. I had a problem here. I don't know about anybody else. It talks about ligands around a central atom. And then even on the same page, he contradicts it by saying, as we all know, ligands have lone pairs of electrons donating into vacant d orbitals on a transition metal. But transition metals are transition metals, and this research question was talking about group 15 and group 16. So again, nothing penalised yet, but I'm thinking, what's going to develop here? We see a list of bond angles. It says bond angle. I assume that it is degrees. We can assume it's degrees. He should have included that. He should have included some uncertainty. It doesn't matter if it's a database or an experimental IA. Wherever there is a number, there must be an associated uncertainty to show that the student has considered precision throughout. Gillespie is mentioned again. In fact, you'll see him many, many times. He then talks about hydrogen has low electronegativity values. That's because it's electropositive, as we know, unless it's in a hydride. So the thing which I'm looking at, first of all, as I'm standing back and just looking at the IA, I'm actually looking at the chemistry before I even think about the rubric, before I even think about exploration, analysis, evaluation. Is the chemistry good? Does the chemistry make sense? Okay, it doesn't matter about the level of the chemistry, whether it's from the standard or the higher, or even this one is trying to go beyond, which lots of students do. But let's see if he succeeds. So he has put an uncertainty in here, 0.1 degrees. That's nice. But again, it's limited to 4. Why could he not continue with the rest of group 15 molecules and include those values? I mean, it's interesting. It's nice to see that antimony hydride is 91.7 and ammonia is 107.3. Okay, we'll park that. We're still thinking. He then starts to become a little bit ravelled up in his own sentences. I don't know if anybody else found this, but saying despite the early successes in VSEPR, some more complex compounds, which is, now this is nitrogen with silicon and 3 hydrogens as 3 bonding, I assume, into the nitrogen. So he's saying a big group differs from VSEPR. That's okay, that's fine. But where have we seen this before? Well, it's on the teacher support material, isn't it? So he's basically using the teacher support material. That's fine as an inspiration. So again, no penalty yet. We'll discuss that shortly. He's talking about planar geometries and bond angles. It would be beautiful here if the student had taken the time to include some images or some space fill models or some ChemMol or any of the drawing packages that you can get to show that he actually cares about communicating his ideas. He's then putting bond lengths in. I don't know where he got that from. Bond angle is compounds to decrease. What's the reference? Again, I'm picking up the ligand. Is it a ligand? I'm not sure. Maybe that was the argument of the theory, but again, I'd need to check on that one. He then makes an error here. Molecules boron, carbon, and nitrogen have shown that the ligand-ligand repulsions are important for AX3, such as BF3, which is fine, in comparison to AX3. But he's already said AX3, and then he mentioned boron tetrafluoride ion. So there's certainly some sloppiness or some laziness creeping into the write-up. On the face of it, it does look really powerful. But looking a bit deeper, it perhaps could do with a bit more rigour in the explanation. Certainly more explanation of the chemistry and of the space fill model. He has gone down the route of including a full paragraph here. I'm suggesting perhaps a table would help, and I'm just making a note here. In exploration, he has certainly got some reasonable material, but only used 1 or 2 sources, and he could have certainly added to it quite easily. So, yeah, we're keeping that in mind. He's not put any limitations, and these must be limited by repulsions between neighbours. You've got oxygen, you've got 2 chlorine atoms with 3 lone pairs of electrons around the chlorine. These will be repelling, these will be pushing each other apart, as well as the lone pair of electrons there. But he's not considering that. He's just talking about the bond angle in the central atom. He's not considering what's happening on the outside. Gillespie, again, the same reference. And then its inconsistency in the VSEPR model can be consistently explained with the LCP model. Well, can it? Because we've not seen any evidence so far. And then it turns out that was actually, how many? 1, 2, 3 pages of preamble. So now we actually begin the IA, and I'm sure you noticed that one of the big things about this IA is it's 27, I think, pages long. Something else to bear in mind. So the raw data is from these data sources. That's okay. I could have given us the link for it. For the bond angles, I decided to use the first 3 sources. So he's already said that he found 5. He only used 3, so he's limited himself. It's also important to note I'll use covalent radii instead of atomic radii. This is sensible. I'm calculating bond angles, and bond angles are produced when 2 molecules are bonded together. Well, they're not. It's when 2 or more atoms are bonded together to form a molecule. Again, there's evidence of a lack of awareness of what it's actually doing. Bond angles, 1 decimal place, agreed. That's good. Data manipulation and analysis. I was not convinced, it was not clear why this student had taken away hydrogen from the central atom's size and then divided by this. It's a measure, it's a calculation. I can't fault the calculation apart from it having no uncertainty in there, but it's not abundantly clear why he has done it. Does anyone have any questions at this moment in time? I realise I'm probably just going into IA moderating mode here. Is there any questions that anybody would like to raise at this moment in time? Okay, I'll look back shortly, see if there are any questions. Okay, so now we've got a results table. We've got no uncertainty, no uncertainty, no uncertainty. Research question, how could we comment on it? I would say that the research question is unclear, but I'll come to that at the end of the marking. Percent difference, okay. Size, but there's a paucity of data, given that there are many websites, and even the one on the teacher support material that's available for all to see, including students, has more references and more molecules than this. So there's a general feeling that the student has rushed and certainly been less than careful with the chemistry. So the experimental bond angle, because for proportionality, I'm not quite sure what he's saying there. They're not empirically 100, and then it's referring to a graph. We don't know which graph. There's an R squared. Where is the graph? To test the reliability, calculate the bond angle from the data gathered and the covalent radii of bismuth from this reference here, and then I subtract it from hydrogen again. If anyone can enlighten me why he's done that, I don't know, but I've looked through his IA and I still can't find a reason why he actually did that. He's consistent though. We're not going to penalise for a simple mistake at the beginning. He's consistently applied it to each one, so he's going to have a consistent systematic error, I guess, throughout his internal assessments. So consistent error, but the rationale is poorly elucidated. Again, we're restricted to 4, but the uncertainties are limited. And then we have hypothesis 2. I think hypothesis 2, what was that? Well, he said a second hypothesis during the preamble, but you have to go back and find it. And this is just raw data. Does he need raw data to use it? Scott, yes, he does need to include the raw data and then include the average data in a separate table. Yeah. But again, it's not too bad. It's not like, oh my god, this is a showstopper, this is terrible. It's not at all. But there are clear areas where if he'd have spent a bit more attention to detail, he could have got a lot more marks than he actually received potentially. So we've got chlorine ligands. Okay, I'll forgive you for that one. This could possibly be the electronegativity of the chlorine ligands has affected the correlation of the graph. Hence, it's interesting to see both the size. Now, this is getting interesting. This is good. Kaizat is asking how reasonable to use ligand. We when we're moderating, I'm probably perhaps a bit more forgiving than you think. The student has obviously thought that all of these atoms donating to the central one is a ligand. And when you're looking at ligand packing theory, which he's using, it does use that word. Strictly speaking, yes, in IB terms, in chemistry terms, it's incorrect because it's not donated into a transition metal. But again, if he'd used it, and then said during this is an oversimplification, or this is a fault in the model, or this is something that we're aware of because a ligand donates into a vacant d orbital, then that would have been absolutely fine. But the fact that he's omitted it means it's not fine. Hope that answers your question. Okay. Then we're down to 3. But then he says, I do not see tellurium difluoride because it stated a bond angle of 180 degrees. Well, it should be bent, but this needs exploring further. It seems like a bit of a throwaway comment. I'd love to have seen a picture of a molecule there and some of the bond angles elucidated. Fluorine ligands again, here's that word. It's talking again. A random calculation here. I assume this is the difference now between bismuth and fluorine rather than hydrogen and the atom which is in question. We then have another calculation which has arrived without any great deal of explanation about where it's come from, and no attempt at precision seems like a common theme throughout this IA. He then goes on to speak about the same things. All discussion suggests a fixed molecule. So that was another thing. All these bonds he thinks are fixed in place, but clearly they're not. These molecules are dynamic things which are moving, and perhaps that could have been an avenue that he could have explored to make this one a bit more of a robust internal assessment. From the observations above, a deeper analysis still needs to be done before proving this hypothesis. I agree entirely. And now we're on page 11. We're on page 11 and we get the subtitle analysis. Okay. So I've seen this, I've read it, it's good, I think you've read it too. Again, precision is omitted, but now we do eventually have 5. And instead of ligand, it could just be atom, Dawn. It could just put the coordinating atom. That would have been a much more scientifically, chemically correct. It could have done bond length or bond strength, correlated it with bond strength. That's a really good one to do. That's not on the teacher support material. I've had that one bandied about though. If you can correlate the bond length with the bond strength and talk about single, double, triple, and do some calculations and use the websites, that's a beautiful IA to do. Again, I felt like you needed a table down here. There's lots of words that you have to dig through. And as a moderator, I must say that tables are an absolute godsend in terms of marking. Okay. In here, I've had to read it 2 or 3 times to try and glean what he's saying. And again, it's limited. It just seems that it's kind of rushed at the end. We now have electronegativities, good, but electronegativity, where's the uncertainty? You should have at least plus or minus 0.01 for the last decimal place. But he's not even done that. And there's only 4 and there's no precision. Now he's talking about reduce the interligand radius. Think about that for a second. What does that mean? I'm not entirely convinced, but I'm not going to penalise him for that. That means I need to do some research as the moderator and have a look, okay, just to make sure I understand what he's saying. This is just a rehash of a statement he made earlier. In molecules with chlorine ligands, the ligand-ligand repulsion is greater than, I guess that's lone pair bonding pair repulsion. Again, we need to see more numbers in here. There are 1, 2 different molecules in here, and only 1 number. It was okay in the end. He pulled himself out the hole, but there's no source, there's no reference as to where he's got that from. And here we have Gillespie again. It reads like he's only looked at 1 or 2 references. It hasn't when it comes to the end, but it's not saying that within his IA. At last, hurrah, we get a couple of molecules which are given. So we have antimony tetrafluoride, I think I've got my glasses on, and NF3. We can't quite see a lone pair of electrons on there. But for all these molecules which he's given here, I would have expected a lot more information about the space fill and the lone pairs and the repulsion. And there's so much more he could have done with this. We're now on page 14. Okay, we've got the summary. Again, no units, no precision. And then it says conclusion. And I remember moderating this for the first time thinking, well, where are all the graphs? I mean, for an IA, even for a database, simulation IA, you must produce a graph. Your graph must have errors. Error bars on the graph would be great. You don't have to do error bars, but at least make an attempt. The IB don't care how we do the uncertainties, as long as we do or consider the uncertainties. if he just takes the last decimal place in this table, which is here now, so for the oxygen, just do plus or minus 0.1 and then plot that on a graph and put the error bars on, happy days. The conclusion, well, that was kind of the conclusion. It does refer to the research question. I would be expecting a hint of treatment of the errors implicit within, even if it's taken obviously from a database. You don't know what the errors were from the data that you've got, but you can at least have a go, and it's the having a go that you're rewarded for. No one expects you to call up the university and say, how do you know this is the Bond angle? But just take the last decimal place. You've tracked the uncertainties, you've ticked the box, happy days, it's all good. Is restated something earlier, which I commented on, but which was not clear then. It's not clear now. Okay. This is poorly discussed. The results were quite confusing, which were inside here. And again, this one reference, Gillespie, seems like he's based his whole IA on this. Interesting, but used numbers. So there's a lot of words. There's an absence of number. And to what extent is this reference, this paragraph about the scale or the direction of the difference between VSEPR and this LCP ligand close packing thing, which I don't purport that we use. Is then copied this. We all know this one. I think if you go to Google Images and put molecular geometries, this is probably one of the first or the second images that come up. And then he just talks about those things. It's textbook. It's not going beyond. There's a lot of potential here, which is not particularly used. Kajal is asking, if the student had not used LCP, but only VSEPR using covalent radiation of the atom, would it be oversimplified? I think it would have been oversimplified, Kajal, is the quick answer. It could still score reasonably well. You could probably get maybe a 5 out of there. If you put the uncertainties in, if you plotted the graphs, if you used lots of data, if you compared with different sources. I think that will become clear when I show you what I believe is a 24 for this year. That will come abundantly clear when I show you the next IA. Okay. No examples were given here. I can see there's a complete absence of references, but then here's my appendix. And I do tell students to put superfluous or extra data or reams of data logger data into the appendix. But this is his IA. This should have been in the body of the IA. So we told him to do this. And now we can see that there is a clear absence of data and information. The scales, they're not the best. We can't see what's going on. There's no evidence of attempts at an uncertainty within here. And these go on and on and on. Hi, Alexa. Hi. So, appendix. Moderators don't read the appendix. So, we don't read the appendix. But look at all this lovely stuff. He's now put the uncertainties in the place where the moderator doesn't read. Would a moderator be that mean as to not use this? No, I don't think that they would. But he's been a bit of an idiot to not put them in, even though there could have been a lot more that he'd done. So, bibliography. Now, this was another surprise as we're reading it. All these references here were not within the IA. We don't know where they've been used and how they've been used. So, I think, as said, it's 6:22. You've all had a chance to have a look at the IA. Would you like to now pop into the chat the score that you think this IA would have got? I have my marks, which I'll share with you when I've seen what you think it should be. And I also have how I was moderated. So the IB didn't totally agree with me either. So let's see. What score would you give this IA? Kajal, give me a number, please. Out of 24. Thank you, David. I'll not give the game away until we've got some more in the chat. Thank you, Sarah. Thank you, Colin. 15, 17, 17. Interesting. We've got 36 people in here. Let's get a few more, please. 14, 17, 15. Gosh, this is actually quite well grouped. 16, Michelle. Yeah. Oh, David, that's a good question. I'll share with you after this section the guidance that moderators are given. It can go. I've seen some things kicked out on the Jenny 18. Generous, very good. So back to David. Sorry, I've seen on the IB Chemistry Teachers Facebook page people saying you cannot go above 12 pages and you must not, or you'll be penalised. It's not like that. If it depends if it's concise. That's the danger. If it's concise and it's got good information in there and it's quality chemistry and all that good stuff, then you could probably go to 13, maybe even 14 pages. But this one, we're at page 28. He's clearly not being concise. There's big empty spaces on the paper. There's many reasons why communication should be knocked down for this IA, not just the poor arrangement and bad use of space within the IA. Okay, so we've got 16, 15, 16, 14, 15, 16, 18, 14, 13, 14 from Kajal. So I think now is the moment of truth. This is what I scored it. So when I score and I moderate, this is what I do. Sorry for my poor handwriting. I prepared this today in the middle of lessons. Personal engagement, I thought somewhere between 1 and 2. Yes, he's tried, and I want to reward that as the moderator. But I'm not convinced. There's too many areas of sloppiness. There's too much unexplained stuff. There's so many things he could have done to give a full 2. But I'll just park that for now. Exploration. There was no attempt at, let's start from the back forwards. There was no attempt at safety, ethical, environmental. It could have linked this to some environmental stuff. I know there's no chemicals. I know there's no issue, no disposal issues, but he should have said that. There are no ethical or environmental issues associated with this IA because it was all data. You can't get the higher bands because there's so much missing. There's absolutely an absence of stuff to moderate. So I'd say around 2, 3 for exploration. Analysis, 3, 4, maybe a 4 on a really good day with my best socks on, but definitely a 3, maybe pushed to a 4. Why? Because precision was not mentioned. The graphs were not within the body of the IA. Evaluation, I would expect. Uncertainty treatment, refer back to the research question. The magnitude of the errors. Why did this website not agree with this website? What happened there? There's no quantification of the errors, so there's no way that student can go above a 3 for evaluation. Communication, if I was having a bad day, I'd give that a 2 because it's too long. There's too many errors. The chemistry in parts is great and in parts is not so great. But if I'm having a good day, it's around about a 3. So this is the key to my moderation approach. So if I'm having a bad day, it's 1, add 2 is 3, add 3 is 6, add 3 is 9, add 2, 11 will be my lowest score. My highest score would be 2, 3, 5, 9, 12, 15. So I always put the mark that I send to the IB equidistant between my worst mood score and my best mood score. I'm sure there's a more scientific way to put that. But I gave it 13. Now when it came back from the IB, they said I'd been too harsh, and the moderator gave it 15. So I think in terms of the range of scores that we gave it, you guys gave it, I think you're absolutely spot on. Because plus or minus 1 is fine. Plus or minus 2 is also fine. Plus or minus 3 is an issue. You might need to look at the bands. But this is the best piece of advice I was given. Most decisions will be borderline between the different criteria on the rubric. So do your worst. Do the best you could possibly give it. Hit in the middle and you're there or thereabouts. Okay. Maybe I was a bit mean that day and should have been more generous in my marking. Or that's what the IB thought. So this document I have shared underneath the IA pandemic video on my YouTube channel, and as I'm sure you guys do, I will go through and I will tick the boxes until that student no longer gets it, no longer ticks that box. So I'm not going to go through that in any great detail. That is there. Again, I will append this under the video after today's session, and you are welcome to beg, borrow, or steal that, as I did. Okay. So, well done, guys. You all just about hit where we ought to have been. So, should we have a look at 24? I'd love to know what you think of this next IA that I'm going to share with you. So, hopefully the difference between this IA and the IA which I just went through with you will be abundantly clear. So, immediately, what do we see? Well, some nice background. I can see references. And it's talking about polar surface area, lipophilicity. Sounds a bit biology, but okay. And hydrogen bonding. That sounds promising. Is there a correlation between the polar surface area and hydrogen bonding between polar surfaces and lipophilicity with a theoretical coefficient of determination R squared of 0.76 as opposed to 0.3? This is promising. The students found a method. They've done extensive research, and they found a method. It looks like a partition coefficient between concentration in octanol and concentration in water. And she's researched extensively. It's quite a simple relationship, but no one's going to penalise a simple relationship. She explains what log p value of 0 means, that it's equally partitioned. If it's negative, it's more concentrated aqueous. And then she links this with the actual blood-brain barrier and how this links with medicines and drugs and how it's available in the human body. Now, I'm already thinking this is good. I'm kind of liking this. She's got university references. It's not Wikipedia. It's not, what's that awful thing that kids sometimes use? Quora, that thing. It's actually an academic, authentic reference. She's talking about hydrogen bonding. It's a stock image, but hey-ho, it's good chemistry. She's a standard level student. She's got different people arguing about what the polar surface area will mean. Shielding, burial of polar atoms within three-dimensional structures. This is good stuff. This is like reading an academic research, which is, the top end of what we're looking for. Research question. Polar surface area demonstrate a stronger relationship with the lipophilicity, which is the log p value, or the number of hydrogen bond donors and acceptors of a drug. Wow, clear, focused. But she's got a number of things going on there, and that's what we need for database. Don't limit it to just one IV, one DV. You can have multiple within there. People often struggle with control variables. This student's managed to find some control variables. The atom-induced polarity in the drug molecules. How's she going to control that? Well, she's talked about the electronegativity values. She's talked about some references here. She's looked at Elmsley, she's looked at Karen and Mundy, and we would look at those references and check them. That's really good. Part 1 and 2 will have independent, dependent variables corresponding to their assigned sub-research questions. So there she's divided it up. So you can see with this one, the last one was really hard to actually find what on earth the student was talking about. This one, it's in your face. You can see immediately what the student's doing. This is a statement of gold. This database investigation, there are no safety, environmental or ethical considerations. The mark is for consideration of environmental, ethical considerations. She's considered it. She gets the mark. She's not penalised for missing that out. She decided to look at 10 drugs. Does that feel like about 10 hours work? Pretty much, yes. She said the databases that she's going to be using, so we can check those out. And then what do we see? We see a table which is akin to the tables that we would see in the experimental or the primary data sort of internal assessments. So polar surface area in angstroms from 1 to 3, and she's taken the average of those with the uncertainty at the top of the table. Just tick, tick, tick all the way through. Consistent decimal places with the uncertainty and the value. This has got 1 dp, that's all 1 dp. This has got 3, that's all 3. Relationship between average polar surface area and log p. So she's done some data processing. Analysis is looking great. She's commented on her uncertainties, love it. And here's a nice graph. This could be clearer. I'm going to get her to sharpen this up, I think, when we before we send this off. This big blue line, which is here on the IA. But she's got a lovely scatter here. She's got the R² value, prime and prominent at the bottom. The scale is appropriate. There are error bars with each of the points. So she can talk about those within here. She talks about difference between different websites. And then she goes on and she does her sums and she does a bit of averaging. Even for averaging, you can still get the marks for data processing, even if you're just averaging. I was kicked out of moderating one year because I said that just averaging is not enough, and the IB said, Mr. Midgley, yes it is. So I learnt my lesson. Even just averaging is enough to get the high bands on analysis. She's commented on the uncertainty. She's got a bit of averaging here, and guess what? There's a beautiful graph there. Yes, the R² value is 0.52, which is pretty sucky. But she comments about why it's pretty sucky. She comments about data and it's authentic data and why it is what it is. We could improve this with a maximum and a minimum gradient, and maybe I'll get her to do that before we send it off. But again, she's researched, got effective PA on the NHBD and NHBA, which she talked about earlier. She's looked at the percentages, and then she's plotted average log P against average polar surface area. So this is gold, because she's actually found a beautiful relationship between the values which she was elucidating at the beginning of this IA. She talks about the outliers. This is a kid that wants to achieve, right? You can just see that. Error bars here. This is beautiful. Average polar surface area. And then as we go down for the evaluation, and I encourage all my students to do evaluation like this, again, compare this with the previous IA that we looked at. If the student puts a table with the limitation, the impact, and the improvement in the same table, the moderator just goes tick, 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 straight through. You're in the mid to top bands. If there's quantification in there, you're in the top bands, okay? Don't give paragraphs and paragraphs where we have to look through all this stuff. I want to see what the limitation is, what happened to it, and what's the improvement. Is the improvement reasonable? Tick, done, top bands. She's got 1, 2, 3, 4 limitations within there, which is pretty good for a database, because you don't know how the experiment was done, you don't know who did it, when did it, all these things. She's restated her research question. You must restate your research question within the conclusion, and she obviously has a suggestion for extension within here. Bibliography, this has all been used throughout, and look at that, just wow, absolutely. I think this is top notch. So, fellow teachers, obviously I can't share this one with you. It's for submission this year, so please don't screenshot it. That'll be much appreciated, or use it. But what are your thoughts on this IA in comparison to the first one that I shared with you? And give me an idea, please, of what score. I've already given you my idea, but I think this is pretty high. What score do you think this IA should receive from the moderator, please? Thank you. David, yes, you can send your IA to me. You can find my email address on the About Contact on my YouTube channel. Yeah. This IA was 15 pages long, and I think the last 3 pages, or 1, 2, 3, the last 3 pages were the bibliography. Excellent. I appreciate I've only skimmed through it and you've not had a chance to fully digest everything that's in there, but clearly I don't want to share this around until it's marked for this year. Brilliant. Thank you, those that gave the feedback. The last thing I wanted to do today, I hope you found what we've done so far useful in some way, is guidelines for examiners. I'm not sure that I can actually share this as a file, but I think given the pandemic, given the COVID situation, given the facts that kids have not been able to access the thing, this is one of the motivators for doing this. I think that the kids have had a raw deal and we need to help them as much as we possibly can. I think I will make a version of this. I'll put it into my own words and I'll share this as well, probably at the end of the weekend. I'm not going to do that this evening. Then I don't get into copyright issues from the IB. But this gives really good guidance on what to do and how to do it, and what personal engagement should look like, and all the other criteria that's in there. So I'll put this into my own words and share it with you. Then I don't get into trouble with the IB for sharing something which I ought not to do. Right, guys, there concludes the my first live stream. I'll stay on for another few minutes if you want to pop any questions into the chat. Thanks, Angita. Don't forget, oh yes, subscribe to my channel, please. Subscribe to my channel. I think I will make this perhaps, I'll give it another 2 weeks. I'll give it another 2 weeks and perhaps do another one if there is some appetite for it. Scott, so you're talking about the second IA, I'm assuming, the one that I think is the high-scoring IA. If so, we actually taught medicines and drugs as the standard level option. As I think I mentioned, she's a standard level student, and she clearly wants to make this something at university for herself. And she was talking about the polarity of molecules, and she was talking about the blood-brain barrier and the what's the word, permeability to different drugs, and we were talking about morphine and diamorphine, doing the usual standard level stuff, and it kind of sprung from there. I would love to say I inspired the students all the way, but I think it came from her. She was the one that ran off and went, wow, I need to research this further, I need to have a look. Oh, there we go, there's Elise, she's in the house, there you go. So Elise, the author, I didn't realise she was there. Hi Elise, thank you. She basically Googled the topic we did in class and looked at Wikipedia to find extra routes for investigation from there. So that was kind of it. And well done, Elise. Thanks for your contribution, Elise. Yeah, the question about the marking of an experimental IA in the future, I'm more than happy to do that. I've got tons of experimental IAs. Is the format like this useful? So do one which needs a lot of improvement and one which we think is perfect? Or would you suggest something else? Let me know, please, and we'll see what we can do. I did ask her permission before we shared it. Thanks, Elise. Right then, guys, if anything else comes to mind, feel free to contact me at the contact email address which is on my channel. Please subscribe, and we'll have another go at one of these in probably 2 weeks' time. Right, good stuff. So we're out of here. Have a great day, great evening, great afternoon, great middle of the night, wherever you are. Thanks for subscribing, and stay safe out there. Thank you. Fair comment, Don. Yeah, I'll make sure I share the sample again in the IB Chemistry Teacher Facebook group before we do the live session. Will do. Signing off, guys. I'm out of here. Take care. Bye bye.